energy, light. Everything you can see comes from light. Let's get this video started with people. Let's go ahead and start talking about, can you see the light? Can you feel it? Can you feel it? Okay, actually it's more, can you see it? Can you see? Okay, let's stop joking around. Now we all know that light is important. Without it, this video would look like this. Now, without light, you wouldn't be able to read, watch this YouTube video, play video games, read books, do anything, to be honest. And you probably know how quickly they travel. And they move at a nifty 1 billion kph. It's the fastest thing in the universe, and it's the speed limit of the universe. Only the Flash can move faster than it. Of that, he can time travel. Hooray for the Flash, I guess, but he does not exist in the real world, unfortunately. Which is why light can hold the secret to time travel. If you somehow move faster than the speed of light, you basically be weight 0, and you'd be heavier than the universe, meaning you are just going to collapse the universe if you somehow go faster than the speed of light, even for just less than a second. In fact, light actually raises a lot of questions. How does it work? Why do stars twinkle? Why are sunsets red? And why did light cause the usually very clever Isaac Newton to stick a knitting needle in his eye? Literally, he did that. And, spoiler, yes, he was okay. He did not turn blind. But, bad news, he got an eye infection, and that almost made him blind. Now, is light made of particles? Well, I'm going to have to say yes. Is light made of waves? Yes, they're both, alright? Light is both particle and a wave. It acts more like a wave, in my opinion, but it's more like a particle in sometimes. In fact, I like to, when I try to draw light as it is, I try to think of a photon that's moving like a wave. Just how fast it moves makes it what type of light it is. Like, how fast it moves makes the colors. Like, how fast it moves turns it into these different types of colors. And that's pretty much how it works. And you can see rainbows in bubbles too, which is why light is refracted inside bubbles, because they're just basically water with soap in them. And soap and water can literally create rainbows. And with that, you can literally create rainbows inside bubbles. And as I said about that analogy about photons moving faster as the wavelength gets shorter or longer, that makes the photon move slower. You actually get yourself different types of light or waves. Radio waves are the shortest kinds, and this is also radio. Microwaves are the ones that you use to cook your food. The one that is my favorite because it includes food. Infrared is the version that you can use your night vision goggles to see, and it's the one that makes you see heat. Visible light is just the light that you can use to see. Ultraviolet light is basically the kind of light that you're basically not used to seeing, and it can harm you, which is why people make you put sunscreen on you so that it can protect you from the sun and not make you tanned. X-rays are still dangerous. They're not as dangerous as this guy over here, but they are pretty useful for seeing stuff inside of you because bones cannot penetrate bones or metal. So if you somehow swallow 100 coins, for some reason someone did this, you can use an X-ray to see where the coins are, usually in the stomach, giving you a really big stomach wummy. And then gamma rays, most dangerous one of all. It's a radioactive wave, and you use that to create dangerous electromagnetic waves. And with the electromagnetic waves, this dangerous one, it can even kill you with long or even short-term exposure. So don't even bother looking at it at all. And light is sometimes invisible. That's what white light is. However, it is not most of the time. Why is the sky blue? It's just how the atmosphere refracts light. And since the atmosphere refracts light, it bounces into the sky. Now, why is the sea blue? It's like a mirror. It reflects the sky. And the sky is blue. See? And that is the reason why water itself is not blue. It's clear. And how fast is light? Light is the fastest thing in the universe. It's even faster than Mjolnir. Whee! It's faster than the Quicksilver from Marvel. It's faster than Superman. Whee! And it's faster than a spaceship. However, it is not faster than this Flash, apparently. Wow. Wow. Apparently there is no speed limit to the universe. There is a speed limit to the universe, but there's no speed limit to the chronoball. And how fast is light? It's like 10 million times faster than the motorway speed limit and 40,000 times faster than how fast the space shuttle orbits. And at that speed, it could zip around the world 7 times in 1 second. At the equator. And literally how fast is it? Well, it's 670 million miles per hour. Also, it's still a finite speed, which is why whenever you look up at the moon, you're looking at what the moon looked like 1.3 seconds ago. Because light takes that long to reach our eyes. And when you look up the sun, do not do that at all unless you're wearing protective gear. You're looking at what happened to the sun 8 minutes ago. Which is bad. Because, well, yeah. And can light slow down? Yes. It can slow down because if it goes through an object, it can slow down. Like, light only goes as fast as speed when there's nothing in its way. However, when it hits something or tries to go through something, it slows down. It's forced to slow down. And that is also the reason why when you put stuff in a glass of water, it just seems to break off and then be placed into somewhere else. And that's what refraction is. And that's pretty much it. And can you time travel? And can you travel the speed of light? Now, if you go at let's say you're going at 10 million kph. That's just 1% of this light speed. Now you're at 90%. Now, it seems starts being wongers. To you, it seems that the car looks the same length, but for people outside, it looks like you're just like this. It looks like this. To you, time goes normally. To people outside of you, well, yeah. At 99% of the speed of light, your car is less than a meter long, and, well, you're 7 times heavier. And a day for you lasts a week for people that are not traveling at the speed of light. And when they try to speak, their words come out slowly, and you're moving faster than them, so you'll probably be gone by the time they finish their sentence. But a letter. And 99.99% of the speed of light is as fast as you can go. You could technically go as fast as the speed of light, but I'll explain why it's impossible. At there, you're literally shorter than a pencil. Like you're shorter than this. And a second for you lasts more than a minute in the outside world. Now, going faster, well, just makes you shorter and slow time even more. And you can never reach the speed of light. Because if you do, you'll be 0 length, heavier than the universe, make a paradox, and time would just stop. I feel like you should go that fast. I feel like you should just go that fast so that you could do everything you want. And what happened if you drove at the speed of light? You'd be literally heavier than the universe, and then the universe would break, and then you basically probably fall into a parallel universe, and somehow keep breaking holes until you become less powerful than the speed of light. And if you want to go back, you have to rev up your engine again. If it runs out of fuel, put in enough fuel, go at the speed of light again, and then crash into loads of multiverses until you get into the right universe. Also, you probably have crashed. You probably have broken it down, and you're probably breaking the multiverse just trying to search for it. And according to this, just by going at 99.99% of the speed of light, you can go to the future. So basically, if you have a younger brother and you go at the speed of light, well then your younger brother is officially older than you. Well, in chronological terms, that is. For you, it feels like 10 years has passed, but on Earth, it'll be like 40-something years. Wow! And that's it. And that is all you can talk about light. Other things that we're going to have to talk about is who's who. Now, this is Aristotle. And he literally thought about if elephants why do elephants fall faster than feathers? They don't. They fall at the same speed. It's just that air can block feathers' falling speed fast, just not infinitely. Archimedes found out a way to kill goldsmiths by showing that your crown is a fake. It's not completely gold. Kill the goldsmith, the king orders. Copernicus said the sun is in the middle of the universe. He got persecuted because of that. Galileo proved... Wait, who's this guy? Gilbert. Yeah, Gilbert. Gilbert basically talked about magnets and stuff, and he would use superstition, and however, he's like, superstition's stupid, I'm gonna test it out. And it didn't work. So superstition's out. Galileo he's probably called a wizard, to be honest. Galileo proves Copernicus is right, and also got persecuted because he respected Copernicus and said his theory was right. Sir Isaac Newton did the worst possible thing in his life, poke something in his eye and make him almost blind by putting an eye infection in him, which is the most idiotic thing he had to do. But he also discovered gravity and invented the 3 laws of motion. And we have... who's this guy? Franklin, one of our founding fathers, a great guy who he signed the Declaration of Independence. Well, one of the signers of the Declaration of Independence. And he even tried to strike a kite with lightning and made him a homemade battery. Yay! And then we have a guy named Volta who created the unit volt and proved that batteries work. We have a guy named Faraday who used magnets to create electricity and vice versa. We have a guy named Maxwell who figured out the electromagnetic spectrum. We have a woman named Curie. And Curie, she's the one who worked with radioactivity. And we can't look at her lab notes because they're already contaminated with a radioactive substance that takes 1,600 years to break down. Wow, that is harsh. We have Albert Einstein, the guy who created E equals mc squared and liked to play the violin and convinced President Roosevelt to go ahead with the A-bomb. And then he immediately regretted it a few years later. Then we have Rutherford, who literally split the atom and explained the atom structure. We have Schrödinger, who talked about quantum mechanics and said a cat can be dead and alive at the same time if he was in a Schrödinger box. They called it the Schrödinger's cat. And there's even a little cute cat here too. Look, superposition. And then we have this guy named Heisenberg, who literally talked about the Heisenberg, who literally talked about war. He also helped the Germans trying to make their atomic bomb. And then he defected. He also talked about the Heisenberg uncertainty principle, saying quantum mechanics cannot be measured to its full extent. Because if we try shorter wavelengths, because original light cannot even hit particles like quarks, if we try to use gamma rays, then first we'll be in danger. And if we try to use X-rays, well, sorry, sir, but the particles that move because too much energy was put into them. So we'll never know where exactly they are. And then we have the soonest guy possible here, who actually died in 1984, is Dirac. And Dirac is all like, he'd helped to advance quantum mechanics. And that's all we have for today and for this whole book. And so until next time, Schneid out. Peace. Is science fun? If it says yes, subscribe.